ilan sa inyo ang working on wildlife? Maybe half of this room, tama? How do you deal with data? Pag sinabi silang habitat association, anong ibig sabihin nun? For example, if you were tasked to do association and describe a Homo sapiens, tapos may kunyari aliens kayo, aliens sa mga yata, and the first time you see a human eating an ice cream, does that describe a human being? Human being is someone who eats ice cream. It's the same. If you're working on a bird species, and you saw it in lowland forest, and you say habitat association, lowland forest. Yeah. In the next hour, we'll go through 3 sort of techniques that I'd like to share with you. Techniques. I mean, I built several organizations using these 3 techniques. Ano yung niche or niche? Do you remember what niche is? 3rd edition of Odum, page 79, second paragraph. A niche is basa. Kaya nyo ba i-define ang niche? There's a niche. With this technique, we'll try to illustrate what a niche is and measure it. Yeah. Hopefully, I can do a good job. With this hypothetical data set, okay lang, no? Species A, it's found in site 1. It's associated with small trees, may undergrowth, not rattan. It's in 500 meters elevation, not associated with water, may 90% litter fall. Can you make conclusions out of this species? Possibly, madali lang, no? This is a species that's a specialist in undergrowth with small trees, mid-elevation, and so on. So, okay, no? I mean, fine and dandy. But what if you have lots of species and then many sites? Anong gagawin nyo? Alam mo kung gagawin nyo? You'll go to your default, you go to your book and say, Shannon and Weiner to. Woohoo! Shannon and Weiner sa McDo. After 25 years. Kala niyo siguro tutulong ko sa inyo, medyo, I'll show you a technique that's quite new. No, it's not. This was first used in 1970s by Cabral. He used canonical correspondence analysis. It's an ordination. So what it does is, yung species mo, species A, or yan, species A to F, kino-constrict niya dun sa habitat covariates. Kaya niyang i-swap dun sa metric continuum of habitat. So what it does, if you use can you program fast? If you run this this is a multivariate analysis. It will give you, it will show you 2 things. One, vectors of habitat gradients. In this case, makikita nyo merong gradient ng increasing rattan of a certain size, increasing grass cover, increasing saplings of a certain size. This is an axis that describes increasing mean canopy, saplings of the saplings, coordinates, and so on. Would it be nice if you have this sort of matrix and say, okay, ito yung itsura ng habitat mo. You have 2 axes, left and the right. The right axis describes your habitat, which is influenced by increasing ground cover and saplings of the higher level. But anong magdoddraw nyo na conclusion if you have an axis na bigger ground cover? Ano yan? Anong klase? Mas mature forest yan, di ba? So you have an axis of mature forest, and you have an axis of increasing grass cover, increasing saplings, mas maliliit, increasing pandan, etc. and rata. Sige, thanks. Hindi, okay na. So what if may laser well?
Kailangan sir saksak.
Laki mo na itulong niya na. Hindi, wala po USB ba?
Ano muna?
Okay na. So you have this matrix of habitats. What if you then use your coordinates of your species in laser? Ang ginagawa ng canonical correspondence analysis, yung next result niya shows you within that matrix kung nasaan yung species mo. For example, tapon scrub fowl is there, striped traveler, and so on. Yeah? So, ang maganda dito sa technique na ito, yung previous mo na matrix of habitats, i-juxtaposition naman niya yung species. With this technique, you can say that the truncated ground babbler is is an anomaly. Ibig sabihin, outlier siya. Hindi siya affected by many of these. The citrine canary flycatcher, medyo dun siya sa axis ng increasing crown cover, but not directly associated with all of these. So what this means is that you can actually go to each species and tell your readers in one graph ano yung habitat association, rather than I've seen reported. I was just browsing through this. A lot of the habitat associations normally get maybe 2-3 pages of your paper. Or in fact, you can just say this in 3 sentences. Yeah. And moving slightly more graphic, kukunin ko lang itong axis na to, ilalatag ko lang ng horizontal. Diyan kami magaling talaga ng horizontal. And get the coordinates. And using Excel, you can show this is your gradient of your habitat from cultivated to old growth. And then here you can actually show the niche of the species. In this case, all of the species that I've analyzed, their niche are positioned in forest. Yeah? Kaya lang, iba-iba yung kanilang niche width. So you have a group of species that are forest species but have wide niche width. Ibig sabihin, mas generalist yan. And then you have a species that is positioned in advanced second growth, but its niche is slightly higher than this. So mas hindi siya tolerant ng early second growth. And then you have a species, for example, blue paradise flycatcher. It's a very narrow niche. So these are species in Palawan. So 2 things I hope you learned today is niche width, niche position, kung saan habitat or forest condition, and then the niche width. Just to give an example of another site in Cebu, if you have the same sort of analysis, you can show evidence that these species here are highly tolerant to forest degradation kasi ito yung kanyang centroids. Katulad din yung kanina yung centroids, kaya lang sinama ko yung ibang kanyang data. So, these are box and whiskers plot, ayun yung kanyang centroids. And here, you're showing tolerance level. This species here can tolerate non-forest, can be found in forest, early second growth. Whilst this species here are forest obligates, pero meron silang certain tolerance. They're forests, but they can tolerate some level of disturbance. So far, okay tayo. Do you think this is useful if you're going to do your thesis? Sana. If you need more, I can email you papers that did this. So okay tayo ng niche. So hindi mo lang pwedeng i-define yung niche based on the third edition ng ODUM, page 79, paragraph 3. Pwede mo na siyang i-quantify. Now, please, do you have handkerchief? Labas nyo lang kasi nosebleed na tayo. We'll go to occupancy. Ano yung occupancy? I'll do a bells and whistle sort of mini stop sa occupancy. Malaki itong subject, but I hope I can give you some tips. What is occupancy? Ano sabi dyan? Basa, fraction of sample units where species of interest is present. So in this room, what is the occupancy of people? Do you think? Mga 70% occupancy. Tama? Would you say so? Or 80? Ganyan din sana sa species. If you're working on a frog, it might be useful to understand how much space does it require to survive in Mount Pagiling, for example. Have you done that in the past? No? Yes? Hello, Earth? Hello? Have you done it in the past? Hindi pa. Or you want to do it, to do something like this? Mga applications ng occupancy, as you know, species distribution, of course, resource selection, and habitat modeling, and this is my favorite, substitute for abundance. Quite a number of my students or my colleagues have always referred to abundance or population, na interchange in population and abundance. Kanya nag-transect sila, tatlong transects, sabi na ito, ang relative abundance is 25 birds of this species. In fact, I read the paper. It said in the span of 8 years, the population of this critically endangered species have increased over 8 years from 5 to 2,000. So yes, ganda sana. But when I looked at the data, apparently they were counting birds of that species in an 800-meter transect. They're walking the transect every month for the last 5-8 years, and have accumulated. Do you think that's correct? Isn't it possible that in that 800-meter transect, they were counting the same species or the same individual? So, do you think that the 2,000 is accurate or correct? Ang tawag natin yan, mind you, bagsak ako sa stat. I took stat 1 twice yata. Besides, ang tawag dyan sa atin ay pseudo-replication. You're counting the same. Yeah? And this is dangerous. I hope you guys will be mindful of that, because those results that you publish are picked up and maybe basis for conservation work. And in this case, sabi niya, safe na itong species na ito, 2,000 na yung ano. Another example, the tamaraw. May nababalitaan ba kayo sa tamaraw of late? How many individuals ang recent count? Do you know? 400, I think last year was about 403, and the year before last was 416. But maybe 10 years ago, it was maybe about 20. Anong ma-deduce nyo na problema dun sa data na? So over the years, 10 years, nag-increase siya from 20 to 400. And mind you, the technique that was done, they'll they'll travel from one vantage point to count tama raw. And then they'll travel the next day to the next point. So hanggang sa sabay-sabay daw yan. And then eventually, what happens is that they come up with 400 or so individuals. Ano sa palagay nyo ang sala doon? Okay. Erroneous ba yun? Sabay-sabay daw yan, ha? Isn't it possible that when I counted the tamaraw sa ito, count ang tamaraw, and then I went to the next day, I went to the next station, 1, 2, 3, 4, 5, 6, 7, 8. Isn't it possible that I may have counted the same individuals when I went to the next station, and so on? Yeah? And so, erroneous and ano. And again, occupancy helps you navigate through those. Again, ang problema natin dito, economics of time and resources. Perhaps almost all of you, all of us, don't have the resources to do complete inventory. Tama? Ang window lang natin, 2 months. Parang pumicture ka ng isang landscape at based on that picture, sinabi mo, ito na yung sitwasyon ng at that point in time, ito na yung sitwasyon ng Mount Makiling, for example. You think that's enough? No. Thank you. So the problem, really, detection is virtually never 100%. Do you agree? There's almost always less than 100% detection. Otherwise, para kayong isang kaibigan namin, shadow pa lang, alam na niya yung species. So, si Andy ata. Ha? Hindi naman. Tapos meron mga ganyan. Shadow pa lang, alam na yan. Ayoko magkunwaring magaling ako. Let's deal with some nerd stuff. Detectability, as a conceptual basis, it's a function of your abundance, count statistics, at saka detection probability. And detection probability, of course, your P, is a member of C as it appears with C, in C. Tama? So, ang gusto lang sabihin nito, yung nakita mo snapshot na yun, yung tatlong tama raw na nakita mo, is a subset of the universe. Tama? Pero yung pagkita mo ng tama raw na yun is affected by your detection probability. What do you think would be the environmental parameters that will restrict you from seeing or limit you from seeing the tama raw? What do you think? Ano mo environmental parameters? Or other parameters? Baka hindi nyo alam kung tama raw yun. Nakita ko nyo ay kalabaw. Tama? So, merong observer bias. Correct? Unless you're really an expert. Second, baka umuulan. Weather. Yeah? Tapos baka sa vantage point mo, may malaking puno doon. Makikita mo ba yun? So, no. So, really, what I'm trying to say is that yung simplistic way of doing detection without taking into account the probability of doing the count without taking into account the probability of detection is quite dangerous. So that conclude ka na 2,000 yung birds mo, when in fact 10 lang pala yun, 15 that you were counting. Tapos hindi mo siya makita dahil may mga environmental parameters na hindi mo na-account. Yeah? So, really, and population ay function ng yung count statistics mo at malaking factor yung detection. Yeah? So, going back to the problem na detection is 100%. Some possibilities, 4 na possibilities. The first possibility, present at detected. Tama? Do you agree? Present siya na detect nyo, walang problema. Go. When it's absent and not detected, okay din na ba yan? It's absent, not detected, fine. But a lot of us, it's present and not detected. but we conclude that it's not there. For example, Philippine eagle is not found in when we were doing the book 20 years ago. The Philippine eagle is not found in Cordilleras, and therefore was not found in Cordilleras, and therefore it's absent. Oops. Sorry. Maling conclusion. Apparently it's there, and in the last section of this lecture, I'll show you an example of a machine learning tool that will help you predict the suitable habitats for key species. Yung exciting. Ito, boring to. So pagka false absence, mali yan, no? Not detected, not present, but detected. Meron ganyan. It is not present, but detected. Maraming DNR na nagaganyan. Nag-count. We were examining midwinter counts for the last 10 years, I think, before the Wild Bird Society did that for DNR. Walang zero. Lahat nung nasa listahan, pink flamingo, 100. Anyway. As scientists, I think that is our moral responsibility. Ensure the sanctity of the data and not to jump to conclusion. I think that's my main message. Ang problema, pagka false absences yan, may negatively biased data ka, di ba? At pangalawa, you reduce the reliability of the data. Tama? Do you agree? And conclusions. So, the solution, I highly recommend that you get hold of this book. Actually, you can download it some of the it's a torrent that you can download. It has, and you can go to the web and download this software called Program Presence. Free yan. Download nyo lang. Tapos meron siyang tutorials. Tapos sundan nyo lang. I mean, it can be a thesis on its own. And I'll show you some examples. Magmamath pa ba tayo? Here, skip na natin yan. Are you familiar with capture, mark, recapture data? Paano ginagawa yun? Pagka kuha nyo, paano nyo analyze yung data? Ibilang nyo kung ilan yung nahuli, kung ilan yung recapture, tapos binabawas nyo. Kaya 20, all in all, 20 bats in one season, field season, and then recaptures ay 10. Ilan ang bats? Ilan ang bats? 10 din. Tatakot kayo sumagot yun. Yung totoo. Dali! I think by saying 10, because the recapture is 10, is false. I'll show you reasons why. Ang assumption mo, of course, dito, closed system. So walang recruitment, walang mortality, walang fecundity, and so on. So just illustrate, by using occupancy, ito siguro mas malapit sa bituka. Normally, you'll have 5 sites. And each site, you have maybe 1 transect. Maybe 5 transects, or 5 plots. So may sample 1, sample 2, in site 1, or 5. In this case, yung 0 means absent, 1 means present. So, dito sa data natin, you have 5 sites. Yung species na yun is present in site 2, present in site 1, present in site 2, not present or detected in site 3, not detected in site 4, but detected in site 5. What is the occupancy? The naive occupancy is that this species is seen in 3 sites over 5. 3 over 5 is, galing natin sa math. Biologist kayo lahat, no? is 60%. With this technique, you're saying that the species occupies 60% of your area. Diba? At last, meron kang quantification. Now, kung ganyan yung naive, kaya tawag namin dyan ay naive occupancy dahil naive siya. Hindi mo pa sinasama yung ano importanteng yung nandun sa p-hat. Anong tawag doon? It's your detection probability. But if you add your detection probability, your occupancy increases because i-add mo yung reasons why the nature is letting you detect the species. Yeah? I'll show you some examples later on. So kung gusto nyo magpaka-nerd, we can download this. Diba? What I'm trying to point out here is that for breadth precision, we should include the covariates. Meaning, sa site covariates mo, it might be elevation, it might be habitat, vegetation, etc. Dun sa sample, at the sample level, maybe observer, time, etc. For example, if you're working on birds, and you did sample at between 10 a.m. and maybe 1 p.m. Tapos yung kasama mo nag-survey ng 5 a.m. hanggang 10 a.m. Where do you think is the mas may bias na data? Dun sa 10 to 1 where bird activity is low. Yeah? So the objective here is to minimize bias. Dito sa software na to, narinig niyo yung bootstrap? With replacement? Ina-assume niya na dun sa sample mo, uulitin niya yung sampling na yan, yung computation by usually I use 999 times para mataas yung precision mo. That includes replacement, so kasama yung missing sample. Kasi nga, pag naglakad ka dyan, kung kanya hinahanap yung tandikan, hindi naman palagi makikita mo. Meron nga siyang dito, may limitation yung detection. Now, I'll go to some tips for your study design. The first one is we want to improve the precision of estimates, diba? And this is influenced by the number of site samples, tama, no? Second, number of samples, and proper sample units. Ang susunod na tip mo dyan, kailangan valid yung sampling plan mo. You should ensure spatial heterogeneity and to generalize estimates to entire study area. Ibig sabihin, alam mo yung lugar mo, kaya mo siyang, well, gusto mo mag-stratify, alam mo yung, na-ensure yung heterogeneity, hindi yung tipong one, sabi mo, forest yan lahat. You have to go to the different sort of strata. So when you've done that, yung study design mo, tatanong mo pa rin, okay, alam ko na to, so why, what, and how? Unahin natin yung why. Of course, pagka nagmamonitor ka, it has to be scientific, and it can be used for management. Yeah? Alam natin yan. But these are not exclusive. So in theory, your work doesn't end up in, Professor JC's cabinet or the library. It has to have some form of use. Otherwise, sayang naman yung ginastos nyo. No? And if you don't publish, and it's not publishable, well, hey, lahat ba kayo sino gusto maging academic? Gusto yung iba nagtuturo na sa inyo? O gusto yung maging scientist? Kung yan ang pangarap nyo paglaki, wala kayong future kung hindi kayo magpapublish, mga kapatid. Yeah? So, your scientific investigation should be for management. And it can be used for monitoring. So, okay tayo sa why. How about the what? The what depends on why. ito yung mga objectives to, the objective determines what will be sampled. And I'll list down some reasons why, perhaps. Occupancy, if you use occupancy, may be useful for understanding land use, may be useful for understanding habitat or habitat changes, or how species utilize the habitat and how much of it. This is from roads. If you're going to be consultants to, DPWH, you have to have this data. Elevation, harvest intensity, and so on. So, okay na tayo sa one. The two important aspects of this. One is detection. Again, babalik tayo dun sa detection. Second, spatial variability. In this case, the size of the sample depends on the biology of the organism. If you're dealing with, Rana woodworthy, what's the sort of size we're talking about, Philip? You think?
Well, it's persist on clean, cool water smell.
And we're talking here of, is it Luzon, Mindanao?
Luzon and
So, quite restricted. What if you're talking about the Philippine eagle? Would you have the same size of sampling units with the Rana woodworking? Totally different, di ba? So, bear in mind those things. And in this case, really, size matters. Okay, maniwala na size doesn't matter. Size matters. Just to illustrate yung sampling unit. Same area, same size, but on your left, hinati lang sa 4 sampling units. On your right is 5 by 5. And of course, ito yung mga species mo na target. In your sampling design 1A, ano yung occupancy ng species na to? Ito yung sampling unit. 1, 2, 3, 4. So it's found in site 1, sample 1, site 2, or sample 2, 3, and 4. So anong occupancy niya? It's 100%. Pero pagka nilit-litan mo siya, 25, what is the occupancy? So saan mas mataas ang accuracy? Sa kabila. So think about that. When you think about your design, think about how you divide up your sample. Or try and decide if this is a sample or a subsample. Sa differential, usually may mga prof na. So is that a subsample or a sample? How many samples, how many repeats? Yeah? Okay. Okay pa tayo nun so far? Oh, baka may mga dumudugo ng ina, wala pa. So, bakit pinag-usapan natin? Next question. Again, same question, how to define a sampling unit? Is there a natural definition? Do you think? At what scales? Actually, wala. It's a case-to-case basis. Again, you consider these 5 questions. Is there a natural definition? What scale do you want to measure? Is the species territorial? Kung territorial yan, siyempre, sa sample mo, territorial yan. And your counterfactual, you sample also places where they can't be found. Palaging sakit yan ng mga biologists. They always sample in places where they are found. Ngayon, babalikan natin why it's not good. Siyempre, density at what density they occur, and the size of its home range. So, Philippine siya na. Now, let's go to sampling units ulit. So, how units are selected determines the result that can be generalized, diba? And each sampling unit within a population should have a non-zero probability of being selected. Do you understand what that means? Ano ibig sabihin nun? Para kung may distance sampling ka, ang first assumption is that the species can be encountered at 0 meters. Ibig sabihin, makikita mo siya. In this case, ang ibig sabihin lang nito, yung mga sasampulan mo ng lugar, dapat kahit ano, kailangan representative siya. Yun lang ang ibig sabihin. Dapat increase mo yung representativeness. Yeah? Third, if units are selected such that occupancy is different to the population of interest, then your estimates may be biased. So kailangan mo pa rin, there are two sort of levels at which you do this, your research. One is you do your test. Hindi yung nag-defend ka ng, hindi defend ba dito ng ano? When I was young, di-defend mo yung ano mo, yung design. Pag dinefend mo, usually babalik sa yung ano, ulitin mo to, ganyan, ayusin mo. But what I found out, through the University of Hard Knocks, you defend it. Once it's approved, you go to the field and test it. If it works or it doesn't work. If it doesn't work, go back to your panel. Sir, hindi po pwede. Hindi yung tipong defense mo ng thesis mo. I did not get results because the transect is very high. Sa mapa, it's really nice to put your transect, but in reality, I think I cannot walk. Wala tayong data, di ba? Ang tawag dito, test it. Believe me, you'll thank me for it if you do it. Pangatlo, if units are selected sa example, survey only at historical sites. Sakit yan ng mga bird people. You will always go to the historical sites or yung usual pinupunta ng bird watchers and survey there. Anong ma-expect mo doon? Check, di ba? Ayaw nila pumunta doon sa places that are not known places for this species. But how can you prove that it's not there if you only went to places where they're there? Diba? Parang love yan. Diba? Pagka si Mr. Right, nakita mo sa isang bar, tapos sabihin sa'yo ng friends mo, baka dyan sa kabilang bar may Mr. Right din. Hindi, wala. Hindi mo pa napuntahan eh. To prove that Mr. Right is not there, you have to go there and see Mr. Right or Miss Right, whichever approach you go. Next, selecting sample units pa rin. It's important to use probabilistic sampling design. Narinig nyo naman siguro yung randomized selection. No? How are we for time? Nasa occupancy pa lang tayo. 444. We can go on and on. Bored na ba kayo? Normally, ganito yung randomized selection. Ano kayo dyan? Familiar kayo. Next, how about when you count variability? Or the objective is to decrease heterogeneity, and therefore the solution is to do stratified design. In this case, it's the same block ng ganyan. Sabi natin, uy, ito pala ay habitat A based on your habitat map, o land cover map. Tapos ito pala habitat B. And therefore, when I stratify it, may samples ako dito, may samples ako dito. So, again, it touches on that very important aspect of research, adequacy of sampling. Kailangan representative. Yeah? Amen? Amen. Second tip, under selecting sampling unit. Please avoid convenience sampling. Yung pinag-usapan natin kanina. Pupunta lang ako dun sa bar na alam ko may mga lusang morals. Diba? Para makapick up. Hindi mo makikita Mr. Right doon, Miss Right. Kailangan medyo Ito yung illustration niya. Ang transect ko, gagawin ko, ito alam ko na dito si Mr. Right, dito lang dadaanan ko. Kumusta naman ang data? Kumusta naman ang results? So, diba? So it will be biased. See what I mean? after all of these, really, common sense should always win over statisticians. Ang problema sa atin, yung statistics mo, kailan lumalabas ng statistics mo sa thesis? Pagtapos na, maghahanap ka, sino bang pwede kong lasingin na statistician sa PSI? Sa secret natin sa lasal. Kasama sa manual, na you should hire a statistician. Mind you, sabi ko nga sa inyo, bagsak ako sa stat. But when I started to understand this, your statistics should be at the beginning. Sa design pa lang siya, hindi sa end. Otherwise, you'll end up, yung thesis defense namin, 25 years ago or something like that, maiyak-iyak kami. My thesis was species diversity along elevational gradients in northern Sierra Madre. First of its kind. We stayed for 2 seasons. We stayed in forest for about half a year, counting birds, etc. First scientific expedition. Pagbalik ko, pogi po, payat ako, shit. Presented. Galing. Tanong sa akin. So, did you run ANOVA? Ay, puta. Anong ANOVA? Bagsak ako dun. And then later on in life, I realized, if I put that statistical analysis in front, then I wouldn't have the problem. Tinanong sa akin, di ba bias yun? Ano yung stratification mo? So please guys, do that in the beginning, not in the end. Yeah? Variations in sampling scheme. Pwede yung multiple days, the same unit, or kasi babalik-balikan mo, or multiple surveys in the same day. Meron kang morning, meron kang evening, etc. Meron ding replicated in space for sample unit. So multiple surveys, so mas malawak yung abot mo. So, tama ba ito? Hindi. Usually ginagawa natin yan, no? When you talk about study design, consideration for number of sites and samples. Again, hindi mo wala-wala ito. Probability of occupancy, probability of detection, necessary levels of precision, and resource available. Now, if you go to the website and look for GenPress, I highly recommend that you download these because it will help you answer all of these questions. An example, this is an output of GenPress, depending on the species that you're working on. If this is your probability of detection, your probability of occupancy. If a species has a high occupancy rate, ibig sabihin malawak yung kanyang range, for example. Pero ang hirap niyang ma-detect, kunyari Philippine Eagle. Sa buong buhay ko, siguro mga 5 beses pala ako nakakita ng Philippine Eagle sa buong buhay ko na hindi yung nandun yung mess at yung mga pupunta ng birdwatchers. Transit. When I did my thesis on the Palawan Peacock Pheasant, in the first experiment, I walked around close to 120 kilometers. Alam niyo ko ilang beses ko nakita yung tandikan. 5. Oh, that worked. Pero okay lang kasi pumayat ako. But without, kasi hindi ko pa alam to eh. And then later on, when I was introduced to this, if your species has maybe 20% probability of detection, and this species doesn't have a wide range, or has a wide range, say Philippine Eagle, ang kailangang number of samples between 14 to 18. Otherwise, kung alam ko sana to, hindi sana ako nagpunta ng 120, naglakad ng 120 kilometers, no? This will help in the economy. Kung ang species ay madaling ma-detect, tapos mataas ang occupancy, kailangan mo lang 2 samples. Yun na rin savings, no? So think about your species, think about its occupancy. Is it wide range? Is it easily detectable? If it is, then work on this assumptions. Yeah. Tried and tested ito. More than 1,000 data points na ito na ginamit ng mga nagpupuno ng scientists. So, general allocation of effort. When detection probability is less than 50%, at least 3 surveys per unit. At least 3 surveys per unit. More surveys will be required when the probability of detection is lower. Siyempre, pagka mahirap siyang ma-detect, mas marami. Like Mr. Right, di ba? Para makita mo si Mr. Right, hindi pwedeng isang sa beses ka lang pumunta dun sa bar na yun. Maybe Wednesday nandun siya, or maybe Thursday. Di ba? Tapos hindi lang yung bar na yun. Pangalawa pala, huwag kayo pumunta sa bar kung gusto makita yung Mr. Right. For rare species, survey more units less intensively. Believe me. And I'll show you an example. Increasing spatial replication with insufficient repeat surveys may not be worthwhile. I'll just show you the calculation. Example, ito yung occupancy mo, 40%. Your probability of detection is 30%. By doing your survey in 20 units, twice, so the 400 times more, your occupancy is 11%. Maso bumaba yung occupancy. Balikan natin yung example dun sa Cebu, balikan mo yung example ng Tamaraw, because you've counted several times. So, ang rule of thumb for us, twice lang. Survey as many sites or many samples as possible, but do it only twice. Pag ginawa mong 5 times, pupunta ka doon sa pseudo-replication. So, mas yeah? Nakakatulong ba yun? So, with only 2 surveys per unit, it would require 500 units to achieve the same level of precision. So, di ba sayang naman yung sayang yung effort. So, that's the end of the theoretical framework. Of course, pagka nag-occupancy ka, pwedeng multi-season, you can work on meta-population, local extinction, etc. I'll give you a work example. This is my work in Palawan. And these are the species. And what the beauty of this is that you work on eigenvalues. Tapos ginagawa niyan, as you model the different combination of habitat covariates. Merong marami, merong konti, constant. The more you have those combinations, irarank niya yung mathematical model mo to show, yung nasa taas na rank, yung pinaka-parsimonious. Ibig sabihin, pinaka-matipid. Kunyari, if you want to describe a person, kunyari si Prof. Pat ay Borta na pogi. Might be 1 million people who are Borta and pogi. Pero you have to add more descriptors para maka-arrive to one na exact. But as you add more descriptors, yung parsimony niya bumababa. So yung pinakamatipid na number of covariates, yeah? So in this case, lahat yan mga pinaka-most parsimonious models. In this case, kunyari, Palawan Peacock Pheasant, its occupancy is 24%. And its occupancy is determined by its relationship with rattan. So lahat nung data points to this relationship. So we tested this. Mas maganda pala example. Falcated ground babbler. This is a very, very difficult species to detect. Kung alam mo yung call, okay siya. Pero when I did this, lumabas sa model. This is influenced by a combination of big trees, DBH, and presence of grass. So, ginawa ko yung template na yan. We went around Puerto Princesa Terrain River National Park. Look for big trees and grass. Voila! It's there. Same with the Palawan Peacock Pheasant. So, if you have this, and I'll just show you some model generated from it. Kunyari, Palawan Peacock Pheasant. 4% nung date of detection of occupancy is contributed by DBH, leaf litter, saplings, rattan, and grass. Pinakamalaking rattan. So if you want to see Palawan Peacock Pheasant, look for places with rattan. Of course, it's a ground bird. So gusto niya yung nanginginaya ng ano. So wouldn't it be nice if you're working on frogs? I had two PhD students who did the same, and it is. So, yung una, canonical correspondence analysis gives you a big picture. Ito yung gradients of habitat variables, but this one gives you specifically which habitat covariates influence your detection. Okay ba? Neat stuff, no? Doesn't that make you excited with your thesis? Right. Okay, now may questions sa occupancy. Makuti lang ito but if we run sessions on occupancy in our office in Tagaytay, just let us know for free. Libre t-shirt. We can run it for you. Last. Okay pa kayo for time? It's now 4:58. Pinaka-exciting dito, species distribution model. Yeah. Tuloy na natin Species distribution model or modeling. Or tinatawag nating SDM. It's a tool we use for management. I'll go through this, what is SDM, etc. Ang ginagamit natin dito GIS. But you use the software called Maximum Entropy. You just download it and it's made tutorials, etc. So what is SDM? Ang problema, ang gustong sagutan ng SDM, really, number one is the linear evaluation shortfalls. What does that mean? Big words, no? Valuation. Valuation! Linear shortfalls. Ano ibig sabihin nun? Anyone can guess? Our results are determined or restricted by our knowledge of its distribution. But all of you, perhaps in this room, know that a 100%, hindi 100% detection, correct? And data is incomplete. So this SDM is quite a neat tool. I'll show you an example later on. Ang limitations ito, again, biological interaction, presence of prey, food availability. We assume that it's a closed system as well. May changes in the habitat. Again, it's because of outdated data or data set and types of vegetation. Sa ngayon, hindi pa tayo magka-ikik kung anong ibig sabihin ng forest. If you use the NAMRIA maps, and Pat will probably agree. Iba yung definition of forest, iba yung definition of forest for us, biologists, for example. So, some limitation. But I'll just show you some applications all of you can read, and how do we do it? Yung pag-aksaya ng panahon, really it's about getting data. And at the end of the day, to us, it's useful because like occupancy, ang occupancy modeling was invented because there are lots of species that are difficult to detect. Konti lang yung data. SDM din ganun. Sa experience namin, you need at least 5 data points of the species for it to work. Less than 5, medyo hindi confident, hindi mataas ang confidence level. And what we do is the species occurrence is pitted against bioclimatic data. For example, these are the list of global data sets that we use. These are downloadable, of course, species distribution from GBIF, etc. Of course, you'll add more data. Paano ba yung SDM? Alam niyo yung face recognition software? Facebook. Or do you use Apple Mac? Diba meron kang photos, you tag yourself, lalagyan mo tutok-tutok ng mukha mo. Tapos, automatically, it will sort out your 1,000, 10,000 pictures or so. Tapos ilalagay sa isang file. SDM works similar to that. These are your environmental layers, at least 30 or so environmental bioclimatic data from forest to hydrology, high precipitation during the driest month, precipitation during the lowest, wettest month, ambient temperature, etc. And then, meron kang 5 data points. What it does is that you overlay these several maps, and then yung pixel na nasa kung saan nandyan nag-occurring species, kukunin niya lahat ng data attributes, tapos hahanapin niya sa kung, kasi picture yan, di ba? Matrix of pixels. It will search for it to show you something like this. And this is Ixos Everetta. And gives you some range of probability. One is absolutely highly probable, 100% probable, 0 not likely to be found. With this tool, kahit 5 lang yung 6 yung data points, we're able to determine that probably 62%, 69% the species may occur in these places. And sana, if you have this, you work it out, dun sa yung thesis outline, you can direct where to do your surveys, your sampling. Hindi yung pikit mata, nandun, pili ka lang. Now you can test the hypothesis and probably there's a 60% chance that you'll find it here. Yeah? And then what it gives you is a probability of, ganun din, parang occupancy, gives you which environmental layer is this species most likely to be influenced by. In this case, hindi ko nalimutan ko lang yung sabihin ng bio 70. I think it's precipitation. And it also gives you this response curves. Itong species, this is another species. Itong species na to, sinasabi, may influence ang annual mean temperature, Philippine annual precipitation may impact din yan. Bumababa at a certain point. Elevation, meron siya, and then bababa din yung probability of detection. Isothermality, meaning yung temperature remains constant over the year. Land cover, medyo iffy, kasi 4 na 5 data points na. Maximum, you get the idea. Some covariates, ibang response na. So imagine if you do one species and you do this, you run it. Tapos yung thesis mo, it's a thesis in itself. Kasi kaya mo sabihin, this species is affected by the precipitation in the coldest quarter, and the effect is this. Beyond this point, bababa ng probability of detection. I'd like to share one key example. The Cebu cinnamon, which is the green one, and the black shell. We know that the Cebu cinnamon, or we used to know, Cebu cinnamon is found only in Cebu. We run the test and I said, shit, ano yun? High probability. That is Camotes Island. And I said, zoom out nga natin. And I zoomed out. And it turns out that it's found in southern Leyte. Sabi ko, uy, curious, we know that this species is found only in Cebu. Bakit nasa Camotes at nandun sa, wala dito. And so I launched a team, took the Cebu cinnamon experts here, they know which species, etc. Took them to southern Leyte. Lo and behold, it's there. Tama yung model. And then we remodeled it kasi may bago ng data points. Tinignan ko ulit, uy, nasa Bohol, nasa Negros, nasa Panay. Sent teams. Boom! Nandun sila. Polillo frog, another example. It's known only in Polillo. But this time, reverse engineer ito. I knew that it's found in other places other than Polillo Island. So sabi ko, pahingi nga ng data. I got the data, played around with it using SDM. Boom! Tama, sakto. Only the Polillo, lumabas yung share model. So, I think by doing that, wouldn't it be nice if you can rediscover, or in this case, I think we have 6 na cinnamon na waiting to be described. Gawin mo na. Walang gumagawa. I have a PhD student who did it. Ang ginawa, kwento lang, PhD student ko, pinagawa ko yung cinnamon kasi nabaffle ako eh. Ang ginawa namin, pareho naman ng cinnamon. Ang problema sa cinnamon, hindi siya yearly na itlog na flower. So, ang problema sa cinnamon, kailangan ma-identify mo siya correctly using the inflorescence. Tama? Wala mga inflorescence. Ginawa namin, sabi ko, reverse engineer natin. Why do you work on cinnamons that we know and then get samples, run DNA tests, and use those genetic markers and say, okay, lahat na nakuha natin, ito mga alam nating cinnamon, ito yung mga unknowns. Lumabas, oh. Tama, and we found 6 new more. There are about 19 or 22 species known cinnamons from Costaman in the Philippines. 19 are found only here in Norway, plus 6. And we discovered more species distribution. So, guys, the field is really, really large out there. When you do SDMs, it allows you to predict where is the survival envelope. And in this case, I did another experiment. And in this case, I modeled for 20 species, individual models and species distribution model. Got the results, put it in, run it in GIS, and overlaid all of the 20 species distribution models from trees and birds, etc. What it showed you, showed us, this is, alam mo Sibuyan Island. Ito yung protected area. And put together, amalgamated the 20 species distribution models. And it showed that these are really, really important sites. In fact, this blocks here, 1 square kilometer is a block. Each block here would have a maximum of 20 species depending on that. So the survival of 20 species depend on those 3 square kilometer block of forest there. So if you have this data, and you have a lot of these species that are dependent on those forests, and the yellow bits, my friend, the yellow polygon is a protected area. Malaki dun sa mga critical habitats, critical space, ang hindi sakop na protected area. And I made this presentation to PNR. Kalahating key biodiversity, totoong key biodiversity area, ang hindi covered ng protected area. And that's the power of SDM. Can show evidence Kasi usually, tayo ng biodiversity practitioners, at the end of the survey, ang conclusion, this place should be protected. Protected area. So, how is that helpful? It's already a protected area. Marami akong nabasa na papers that makiling should be protected. So how is that helpful? If you go back to your niche width and niche position, and occupancy, and SDN, balikan nyo, i-recommend nyo. This shows inadequacy of the coverage. It shows you hot spots. And so on. And, okay. Okay ba yan? I'm at 5 total. I think I need another 5 minutes. Bigyan ko ng kwento. Bleeding heart. Close my heart. No pun intended. So we know that this species here occurs there, that species occurs there, etc. So, we know that it's highly threatened species. What to do? So we ask the question, what is the habitat preference? Where are these habitats found, and what is the condition of the habitat? And third, what is the future for the species? Siyempre, gagamitin natin yung tool na ginamit natin kanina. Mapping the habitat, the niche width and niche position. Your Negros bleeding heart, its niche position is in forest. It's a strict forest species. It cannot tolerate other habitats, not forest. Tapos, specialist ba siya o generalist? Specialist. And when we looked at SDM, species distribution model, we looked at the response curves to different bioclimatic factors. Alam niyo lumabas, interestingly, pinakamataas na score ay isothermality. My friends, this is the first evidence that this species is directly affected by climate change. Anything, if the temperature, ambient temperature in the forest increases by more than a degree, then the species is pushed to the brink of extinction, as it is more pushed to the brink as it is right now. So these are incontrovertible truths and data that you can use. Yeah. Siyempre, lalabas ko yung natin yung mga pala just to illustrate the gravity of the problem in Negros. And this is how fast degradation or deforestation has happened. And using SDN, so alam natin na konti na yung guba. But this is old data. So I modeled the Negros bleeding heart and used the 1988 Landsat image. So parang ginawa ko rin parang CSI, I recreated, based on the species occurring, I recreated or modeled a situation by which the distribution of the Negros bleeding heart would have been using the 1988 forest cover map. Kasi alam natin na forest dependent siya. Next. And then I used the 1994 one. And then I used the 2010 Landsat images. Ano nakita niyo? Sige, ano ko naman. I'll change the colors. It's just showing that this one is your distribution 2010. And this would have been the distribution in 1988. What can you see? Over time, in Negros, this species distribution model has fragmented. I have, well, hindi ko lang naisingit. The Tamaraw shows you the same. Nag-contract yung kanyang distribution. If, for example, in the Tamaraw, if assuming the 400 individual count is correct, nakakoncentrate na lang siya sa isang maliit na kapag meron ka isang hayan, sort of typhoon, that would have wiped out the entire population of Tamaraw because they're concentrated in one on site, potassium risk. Breeding heart. Wouldn't that be a nice paper for you to do? Think of a species and do SCM. And then the other thing that we do, hindi na to kasama sa repair. Kwento na to, chorba na lang to. We have hobby namin ito, naglaro ng mapa. Use the Alice Pulsar in 2007 and 2015. So medyo mataas, fairly high yung accuracy rate. We were asked, of course this is, we're allowed to disclose it, but just to show you, this is a, alam ni Pati ito. This is a power plant, and this is the development block. Ito yung, ang tawag dito, service contract area, and this is development block. So we look at the forest change from 2007 to 2010. The red bits you'll see are changes from forest to non-forest. And then the green bits you see are forest biomass increase from 2007 to 2010. So yung gray, no change. Forest pa rin, no change. So across southern Negros, we see lots of biomass gain, right? The full majority, kalbo-kalbo lang lalo pa siyang numinipis. So a lot of degradation. Eh, kumusta naman yung bleeding heart mo? Now you can juxtaposition your bleeding heart species distribution model and this. And to show, say, kaya ginawa ulit, pinagsama-sama, pinamalgamate ulit yung, in this case, 32 species of threatened trees and birds. It shows that a lot of these key areas overlap with the development block. However, outside of the development block, ito yung mga high conservation value areas for biodiversity, and yet, day in, day out, they face this high degree of degradation over time in only 3-4 years. Doesn't that scare you? It does scare me. So, application. And then you can go back to this. Rather than the old way of doing it, consulting firms will hire you, will ask to walk transects, pogi, pagbalik mo na, there are 100 species, X% are Philippine endemic, X% are Luzon endemic, so fucking what? Hindi mo rin mabigyan ng a lot of these EIAs end up nothing because we only share a list of species. It doesn't mean anything. But if you go to, to an industry and say, mga kapatid, yung development block mo, kalahati yung high conservation, yung key biodiversity areas are threatening your key biodiversity areas, then you have incontrovertible truth. You have evidence. So bottom line, go out and do your science better. If you don't, you have no business being called scientist.